Okay, cool. Yeah, so this is the first meeting for EVMMAX. Um, do people want to sort of just quickly introduce themselves and sort of where they're coming from, just because the meeting's quite small?
Sure, I can start, I guess. My name is Chance. I am from the PSC team, Privacy and Scaling Explorations, which is funded by the EF, and we do a lot of ZK and MPC research, among other things. And so I'm interested in seeing this because most of the stuff we do is based on modular math.
Thank you. Lewis, maybe Lewis can't speak. Score Badger.
Hey, yeah, this is my real name is Amir. I believe I met some of you at DevCon SEA. I'm with the JavaScript team. I'm working on the Ethereum JS execution client. I'm interested in implementing the EVMMAX EIPs with the JavaScript client and potentially working on some of the EIPs and some of the open questions and work in the EVM Max space currently. So,
Okay, nice. Dano, we know who Dano is, but uh, yeah.
Yeah, mostly work on EOF right now.
Mm. Radek,
Yes, I'm Radek from Epsilon team, and I'm working on the EVMMAX spec with also an implementation in EVM1. Yeah, so I'm also interested from the perspective of how the spec is specified and the potential use cases it can be used for.
mhm. Piotr.
Hello, I'm Piotr from Epsilon and also work on EVM1 and EOF currently, and in the future on EVMAX as well.
Nice. Andre, I think you're also in Epsilon.
Right, yeah. I'm Andre from Epsilon team. I wasn't that much involved with EVMMAX yet, but trying to follow the latest developments.
Mhm. And Lewis, I think so.
Yeah, Louis. I'm from the BESA team. Working or started working on EVM as well, and I'm looking to follow the EVMX and looking to implement it on BESA as well.
Okay, that's nice. And Elias wrote in the chat that from Kakarot ZKVM team, implementing EVM in Cairo ZKVM. Cool. Yeah, and I'm Kev. I'm currently in the EF, mostly doing applied cryptography. And yeah, I'm really interested in EVMX and seeing where we can take it. So the first thing, I guess everyone has a sound understanding of what we're trying to do in EVMX. If not, then um, I can explain, or Dano or Jared's kind of left the chat can explain. Does everyone sort of have a concrete understanding of what EVMX? I'm happy to get a quick rundown. Yeah, so EVMMAX essentially adds these modular arithmetic opcodes into the EVM. And it just allows you to do it should allow you to do modular arithmetic a lot cheaper than implementing them in raw solidity. The specs for it, I can link it to EIP 6690. And one of the sort of goals of EVMX is so that you don't need to re-implement precompile for every, for example, field or curve that you want to have. So currently, like if you want to support cheap, let's say BLS 12381 edition, you need to have a precompile for it, which is EIP 2537. But with EVMX, you can have something that's not as cheap as a precompile, but definitely cheaper than implementing it in raw solidity. Does that, Elias, does that answer your question? And does anyone want to add to that? Cool. Yeah, so on the first thing on the list is what was done till now. So does Jared, you're back on the call. Do you want to sort of explain the progress that's happened on your side?
Yeah, sure. Hey, so just on my side in the last couple of weeks. So we back in early 2023, I posted a draft proposal under EIP 6690. And in the last week, so about a month ago, I posted another draft proposal, which was an updated version of 6690 based on kind of the feedback since, and also talking to Vitalik about what he envisioned as being useful. So I've since updated EIP 6690 to reflect this draft spec that we've been talking about. Uh, so I would say, yeah, in addition to that, in the past, I think there was a period of time where there was a question whether the BLS precompiles were going in or not. And so at the time, and this idea, EVMMAX being the main competing idea. So I implemented a few of the operations, the BLS operations. So in the past, well, today actually I posted. Sorry, when I say I implemented a few of the BLS operations, what I mean is that I wrote them in assembly using EVMMAX. So today I posted a link to the tool I used to build them. It's updated with EIP 6690. So I think that's been the progress from my side. Yeah, maybe Epsilon can chime in. I know they've been doing a lot of prototyping work as well.
Yeah, so we also implemented kind of a version of the EVMMAX spec, but on the top of the EOF, so using immediate arguments for the instructions. Based on this, we implemented a couple of simple BN curve precompiles counterparts implemented in the using this instruction set. And so it was, I believe, point addition and point multiplication. We also had some version of easy recovery, but of course, easy recovery precompiled from the current spec. And yeah, and this is implemented on in the EVM1 for now. Yeah, and that's basically all. We also had prepare some document which sum up the outcome, the feedback from this those implementations. Yeah, so that's all we did, I believe, or I forgot about something. So maybe someone remembers better.
Okay, and so I guess that's it from mainly the client side of things. I guess no other client has sort of started an implementation. Is that right, Amir and Lewis?
Yep.
Mhm.
No
Yeah.
progress so far.
Not yet.
Okay. I think probably the first steps for if you're a client looking to start is to figure out the cryptography, like the library that's underneath that does all of this modular arithmetic. If you guys ping in the chat, definitely happy to like help you look through which ones are suitable. And in terms of the first use cases that we want to target, Poseidon's the one that sort of comes up quite a lot. Are people happy to target Poseidon first instead of some elliptic curve? We can also do BLS12, for example, since there is a precompile for it.
I think Poseidon is a good thing to start with. One thing that I was thinking of is when I was benchmarking performance of like Montgomery versus Barrett, the numbers were not super convincing for a single Poseidon because it's not enough modular operations. But the thing is, we very rarely do a single Poseidon hash when we're doing something useful. We'll typically do a minimum of like 32 Poseidon hashes for like mutating a Merkle tree or something like this. So perhaps like
You
Poseidon
went
hashes
quiet.
instead of one.
You broke off. Chance.
Okay. One moment, hang on.
I think maybe was you saying, oh, wait. Okay. I don't know if Chance can you.
I'm sorry, my internet cut out.
Cool.
Okay. What I was saying is instead of benchmarking one Poseidon hash, I think we should benchmark a minimum of 32 when we're considering Montgomery versus Barrett, which is maybe more specific than what you're asking, but that's what I was trying to say.
Right. So I guess Poseidon would be implemented inside of the Solidity contract. And you're saying that, so with EVMMAX, we have EVMMAX memory. So once you put something into EVMMAX memory, we do this Montgomery transformation. And once we take it out, we do a Montgomery transformation. I guess, are you saying that if I have input and I put it into EVMMAX memory and I do Poseidon over that just once and I take it out, it's not, the performance of that is not great?
Yeah, exactly. The cost of moving in and out of Montgomery is too high.
Okay, that's
Sorry for the
interesting.
question, but how big is the output from the Poseidon hash?
Could you say that one more time?
Okay, how big is the output from the Poseidon hash?
Oh, it's
So
constant size. It's like
constant.
one field element. If it's like 200, it's gonna be like 256 bits.
Okay. Yeah. Okay. That was. Yeah, just wondering if it really makes some real difference to. Okay, first of all, if it's really needed to take it out from the EVMMAX memory and put it back, that's first thing. And the second thing is if it's really needed, does it make any difference if it's so actually small? Yeah, okay, that's something which has to be investigated. But good point that we have to check it.
I think
Just to clarify, sorry,
sorry.
were you saying to the base field width here is 32 bits and we're just talking about like field elements, not like extension field or any of that? Like we're just talking about single 32-bit numbers as what we're computing Poseidon over, right?
It could be. Oh wait, I don't even know if you're asking me.
I don't think it would. I mean, I think for Poseidon, it would be parameterized over a field, right? So it just depends on what field you're doing it over. I would assume that we'd start with a 32-byte field. That's what I would assume that Chance was doing it over. It is super interesting, I guess, and quite a bit unintuitive that one Poseidon, the operations that you do inside of Poseidon is not enough. As in the coming in and out of Montgomery somehow is still a dominating cost. So I think it'd be good to investigate that. I didn't think Poseidon was that fast. I thought we was doing quite a lot of multiplications.
Yeah, it does like 1,000 multiplications. This could also be a problem with my benchmark code.
Are
And
those
what's-
numbers based on the JavaScript performance?
No, this is based on a Rust implementation.
I see. Okay.
And was this also doing a Montgomery transformation on the Poseidon constants?
No, that was without that was assuming the constants were already in Montgomery form.
Okay. Yeah, it'd be interesting to see this, maybe if there's some code, because it's super unintuitive. I'm probably missing something here. Cool. So I guess are people happy with focusing on just the Poseidon use case for now? Just because it has a lot of details in it that I think we need to iron out anyways. Like for example, the constants that are used in Poseidon, we ideally don't want to be putting those in and out of Montgomery every time you do a Poseidon hash. So we have to figure out some way to deal with that. And I guess from an algorithmic point of view, Poseidon is a lot simpler in order to implement than, let's say, some EC, some elliptic curve arithmetic. Anyone against sort of using Poseidon as the first use case that we try to aim for?
Yeah, I think it's a good idea to start with Poseidon.
Okay, cool.
So can I just ask there? So I've seen, like, it seems from my layman perspective here, having tried to glance at the resources around Poseidon, that there's a few different configurations in terms of how many constants are used. For what we're targeting, what size of constant table are we looking at?
So this depends on the field that you instantiate it over, as well as the number of inputs to the Poseidon hash. So yeah, we should definitely define this so that we're all benchmarking the same thing. I'd say we could just use a 254-bit field and 2 input elements, which would be, I think, like 60 rounds, split between partial and full rounds. Yeah.
So can we have a or maybe we already do, but I'm interested definitely in some use cases of using Poseidon, not only the implementation of the Poseidon itself. So it would be very helpful, especially the case when you need to calculate many Poseidon hash in row.
So
Right.
you're asking, wait, are you just asking for an example use case where we would do that?
Yeah, exactly. Because it's I wanna make sure that we're on the same page. So
So the biggest use case is maintaining like a Merkle tree that exists on chain and opening it or mutating it. So if we have a Merkle tree of depth 32 that can store 4 billion elements, then we have to do 32 Poseidon hashes anytime we add a leaf to it or change a leaf within it. That's the use case I'm thinking of.
yeah, and this Poseidon hash and this constant array. I'm newbie here, but in this topic, so this constant array or this constant matrix used in Poseidon is the same matrix for all the Poseidon calls, or you change it?
Yes, it's the same for all of them.
Okay, great.
Or I should say it's the same for all of them for like a single application. But if you change the field, then there will be different constants. But
Yeah,
for
sure,
like a single,
sure,
yeah,
sure.
okay, yeah, cool.
Yeah, sure, I understand.
And one thing that Jared brought up inside of the GitHub issue is how do we plan to sort of iterate quickly on these contracts? So like, what is the pipeline to implementing Poseidon? And if we need to change something really quickly, what is the pipeline? What if someone wants to implement BLS 12 edition on the side? What sort of tool are they going to be using to quickly iterate? So currently,
Yeah, I'll just chime in and say that from what I've done, my I would personally opt towards using something similar to so I presented this tool EVMMAX BLS 12381, which is essentially it's people here may have used like templating systems before. So this essentially builds it is a templating system that generates Huff output. So when you write contracts with this, you are well, you're writing Huff code, but then you also have the ability to call into Python to generate more to generate part of the code. And maybe people will opt for a different route, but it seemed like for quick iteration, having something like this where we have an assembler with the basic EVMMAX support, and then we have the ability to just generate assembler code with a higher level language. I think that to me sounds like the easiest way to iterate. And from what I've seen in the past of how people write these like low level crypto contracts, and I'm just thinking of zircon lib as or zircom as my frame of reference. I've seen people use basically generate the resulting code with a higher level language. But maybe people have there are other opinions here. It just seems like that would be the easiest way to start off with.
Yeah, so just to clarify, if I wanted to create the BLS, a BLS 12381 elliptic curve implementation using this, I would need to, well, first of all, I'd be writing Huff code. But for the EVMMAX opcodes that I want to insert into the Huff code, I would write that in Python. So is that correct? Or
So what you would be writing Huff, but like the big problem to invoke the EVMMAX opcodes, you are it would be easier if I could show you, but essentially you are assigning symbols to ranges of the EVMMAX memory space. And then when you invoke the opcodes, you are invoking them with the the text symbols names you've predefined. So yes, you are invoking them in Python, but it is very much like embedded in the Huff code.
okay, I see.
But then like I said, if you want to do something a bit more complicated, you can just write a template method where you implement whatever it will emit, you implement that in Python.
Okay, I see. Okay, and the EVM1 currently, Radek, you can correct me if I'm wrong. I think currently there's just like a library that you use to just adding.
Yeah, just a simple library which allows you to generate the code with the EVMMAX instructions. But it's not very convenient actually. So it's more for like you use it to generate EVM tests basically or mainly, and yeah, so we extended it to generate also these additional instructions, but it's very low level. So definitely we need something. If you want someone to prepare some use cases on the top of the EVMMAX, we definitely need something more convenient. I haven't looked at the Jared's tool, but yeah, I'm curious and I will definitely do it soon. Yeah, so we had some idea with YOL with implementing support for EVMMAX opcodes in YOL, but not sure still because we haven't started doing this yet. So not sure if it's the best way to do it. So yeah. So this is something we needs investigations.
Okay, and I guess Chance, was you also going to look at Jared's tool? I can also take a look to see like how convenient we think it is and whether there's anything better.
Yeah, I think just looking at the Python just now, it looks pretty convenient. But I have concerns about actual flow control in the EVM. Like, I think the operations will be very fast, but I think having to write the logic around the operations might increase the gas cost significantly. So I'd lean more toward doing some like hacky thing in Yule, and then like writing a script that like sort of pseudo evaluates the gas cost there.
Yeah, so that's actually a really good point. because that is totally correct. With the EC mole implementations, the majority of the overhead, well, let's just say conservatively, maybe half of it or more is in the non-EVMMAX opcodes and the control flow, and it's so yeah, that's gonna be the hard part about writing contracts in in a low level language in assembly, right?
Yeah.
Yeah, that was also my impression when we implemented the CC recovery. That the most, maybe not the most, but a lot of gas was used to just jump in the loop or just on the control flow. Yeah.
Yeah, I mean, like stack operations, just manipulating stack. I know people have been talking about repricing non-control flow EVM opcodes to be lower, so maybe in the future that will kind of help alleviate this issue. But right now, I mean, yeah, depending on the use case, it's problematic.
But you mean the stack manipulation regarding the implementation of EVMMAX without EOF, yeah? In this case,
No,
or,
I just mean
in
like
general?
so in the EC mole in the like double and in the it just does a loop, right, where you're reading bits off of a scaler and doing stuff based on those bits. Just the stack manipulation and the bitwise operations involved in doing that loop and reading the scaler are
Yeah,
have
exactly.
high
You
gas
reminded.
overhead.
Yeah. You just reminded me the code I had seen before. Yeah, thanks.
So maybe it makes sense to possibly explore the Yule route, just because it might be more indicative of the actual gas costs of EVMMAX once you implement it. I'd still be interested to have Jared's tool, because if it's easy to use, then initially we could at least have some gas cost numbers, like if it's just really easy to use.
Yeah, I can update the gas cost numbers for the BLS operations and give a breakdown of those if people would be interested. I guess I'm curious why people think Yule will be more efficient than handwriting this stuff.
I don't
Or
think
I
it'll
guess
be.
Kev, those.
Oh no, sorry, I might have misspoke. I don't think it'll be more efficient. It just seemed like it would be more indicative of the actual gas costs. Like if someone was to implement Poseidon.
Yeah, okay.
Yeah, let's check these two directions. Yeah, so we definitely can check you and just in the end of choose the one which will be the most convenient for the cryptographers. Yeah.
Okay, cool. And I guess one other thing from the GitHub issue, or more generally, is like, what is the status of the EIP at the moment? Do we have the correct gas cost numbers, or do we need to do more investigations to figure out what the gas pricing should be for these new opcodes?
Yeah, I can comment. So I think it would be great to get feedback. I kind of took, well, I updated the IP based on my own accord, based on what we have been talking about for a month, and I felt like this feature set that I included here was kind of the rough consensus of things that we are looking at prototyping and researching around. Regarding the gas model, so one thing that will likely make a big difference in the end. So this gas model is based on my implementation of the arithmetic using Ingo and based on what the authors what the Gnark library provides. So, for example, if we from my benchmarking, it's about 2 times the overhead of if we were to create an implementation that would use handwritten assembly for the arithmetic. So I don't really know where I was going with that, but
I guess what is the methodology for pricing these opcodes? Like, for example, let's just take malmod X. Is it the same methodology for pricing precompilers? Like, how do we determine the cost of this? Is it relative to Ketchak or?
So what I did was I based it on the current pricing and performance of EC Recover in Geth. So I took a benchmark of the EC Recover precompile, measured the gas throughput from that, and used that as a target. And so the implementation of this, the gas prices used here are based on the cost of the arithmetic and then the cost of interpreter loop overhead in Geth. So to measure the interpreter loop overhead, we simply just create a piece of EVM bytecode that does these operations in a loop, and then I take the price of the cost, the runtime of the arithmetic itself, subtract it from that, get an idea of the interpreter loop overhead. And then another like assumption here is also that the amount of memory we can allocate in EVMMAX in a single call context is not enough to influence the runtime in the worst case, meaning that the latency of memory does not become a factor here to a significant extent.
Yeah, we can also prepare some benchmarks from the EVM1 side, comparing also to EC Recover or to any other hopefully well with well designed gas schedule. Yeah.
I have a question to Jared, to the gas costs. If particle gas would be available, would you set one of these gas costs of 1 to sub 1 values?
I didn't see it on the screen, but who is asking that question?
Piotr.
Oh, yeah. I think so. Yeah, for a lot of.
Okay. Because there's a lot of ones in the table. Yeah.
Yes. I mean, so yeah, something we could look at doing is revising the gas model so that because with 6690 you can invoke you can do multiple arithmetic operations per opcode. So I think that per operation we could look at going sub 1.
Right.
Definitely. Because like a lot of them are really cheap. I mean, addition and subtraction are very, very cheap. And then the multiplication at low widths is also very, very fast.
Yeah. So, thank you. So for the sake of the argument, maybe it's worth to quote this as particle gas cost, even if that's not available to be actually charged for one operation.
Yeah, sure. I mean, that kind of conflates with the previous particle gas cost per. Yeah, sure. Yeah, we can figure out a way.
You don't need the particle gas proposal to pass to charge less than 1 because of the strided operations, right? What you said.
I think that you could charge less than 1, and then round to the nearest. Round to be a whole number.
Yes.
Like
in the scope of a single opcode, you would need the strided opcodes that you have right now. So anyway, yes. I guess for the sake of the argument, I think it's worth to quote less than 1.
I'm saying the cost of the invocation of a single opcode should be a full number, but
Yes.
the individual
Yeah,
operations
exactly.
within that can be
Yeah.
someone. Yeah.
Okay, thanks.
My understanding is that we usually price precompiles based off of EC recover, whereas these are opcodes, and we're also pricing them based off of EC recover. Like, is this okay? Is this like a sound way to price opcodes?
I'm all ears if people have alternative proposals. This was the easiest way to assign a
Yeah.
cost model.
But if it's okay or not, I think nobody answered this question yet. Yeah. So, but I think that's the most common way now we get to prepare discuss the gas schedule for precompiles.
Okay, I see. Yeah, I guess we can put it in the questions to see if anyone has a better idea. But yeah, if there's no better idea, I think we can just move forward with this right now. And the cost of a addition, I guess this goes to Piotr's question. So the cost of just a 256-bit addition is now the same as malmod, is that correct? As in it's
As a 256-bit molmod.
no,
Molmod
so
X.
if I was just adding two integers together in Solidity, is this now the same cost as doing a malmod X?
I think so. I think it's either the same or it's like one off, one less maybe.
Yeah, I guess this goes to the not using whole numbers for the gas cost, but I guess that does seem a tiny bit off.
So you're talking about the current molmod opcode, molmod admod, right?
Yeah, so in the EIP, the EVMMAX EIP, we have malmod.
Oh, okay. You're talking about the ones in EVMMAX because we have them in the EVM.
Yeah.
I would have to look up the cost model again, but
I mean, so you mean the 256-bit modules, right?
Yeah, so if I was just adding two integers together, the cost of that relative to doing a malmod X.
So malmod is 8 gas right now, and malmod X is 2 gas per Jared's table in the EAP, from what I see.
the cost of an admod X or a submod X for the cost model I proposed is 1 at 256-bit widths.
Yes.
It's 2
and 2 for
per
molmod.
mol. Yeah.
And 8 for molmod in the EVM, like the current one we have.
Yeah.
So it's much cheaper in the EVMMAX.
Yeah, sorry, maybe my question's like misformed. So without EVMMAX, I can add two integers together. The cost of that relative to in EVMMAX, I can do a malmod X, the cost of that. Does that
2
make
to 8.
sense?
Yes.
Okay,
Or
2
8
to
to
8.
2. 8 to
Okay.
2. EVMMAX is cheaper.
Okay. Makes sense. Yeah, so I think the gas cost numbers are we still probably need to justify them a bit more, but it doesn't really stop us from getting this Poseidon example down. And in terms of on the to-do list, I guess the Besu and ETH.js folks, if you just ping inside of the EVMMAX channel, we can talk about sort of the cryptography and the API for it. I did have a Geth PR, which had like a big int library, so like a simpler implementation that can probably be easily ported to Besu and ETH.js as a big, like just to start off. I can link it inside somewhere.
A quick question. So what cryptography needs do we have that we would need an external library for a client implementation for EVMMAX?
You just need to be able to do modular multiplication, modular addition really quickly. So you could use in JavaScript, you could use the big int sort of new native type. But it's probably not going to be fast. So eventually you're probably going to want to use some specialized modular arithmetic library.
I see.
Okay.
So like the implementation of add and it's only the MOMOD algorithm that is complicated. The implementation of modular addition and subtraction is very, very simple.
Okay. Were there any questions from anyone else? We've gone through all of our items on the list.
Yeah, I wanted to talk a little bit more about pre-formatting Montgomery values for use in the EVMMAX. I think this is really important, and I think it's also like relatively simple to do. We just need to spec out how we select the Montgomery constants for EVMMAX for a given modulus, right?
So the problem, just to clarify, the problem is that we have constants for Poseidon and we want to be able to sort of pre-compute them into Montgomery form.
Well, it's not just that. It's so, for example, if I have a solidity function that accepts an argument that is going to go directly into EVMMAX, whenever I send that transaction, I could pre-format that argument in the transaction call data in Montgomery form if we support this.
Yeah, but we don't support loading and storing, and basically we don't want to the interface to make visible the Montgomery form of the values in the contract. Yeah, we want to make it.
I think this is the question to be able to, I mean, to sacrifice the purity of the API for pragmatic reasons, right? Because it's going to be much faster.
But there are other solutions also we can consider.
Yeah.
Just like for example, we can extend the IP with additional section in the URF which have this or which has this values already pre-computed, and they will be loaded directly to the EVMMAX slots or registers without any conversion.
I'm really skeptical that this will actually be a problem in practice. And I also feel like, yeah, I mean, we could add them to a section where we choose some consensus Montgomery parameter, and then that's not, I mean, we make that unobservable to the code. But then if for some reason in the future we have a new multiplication algorithm or some new Montgomery reduction algorithm comes out that doesn't use those constants, it kind of creates an awkward situation with the existing code.
What would be, so first of all, I disagree. I think in practice this will be a large bottleneck, but I guess what kind of change would you expect to see to like the Montgomery algorithm that would break this?
I don't know. I mean, I'm thinking like even beyond, like if something unrelated, if some other, I don't know. I can't predict how things will develop, and I mean, it's safe to say that Montgomery arithmetic reduction will stay around, given that it's been here since the 80s and it's kind of ubiquitous at this point. I think it seems weird to tie consensus to a constant that is very much dependent on the hardware of the machine in question. and specifically the word size of the machine in question, right? Because
Is it based on that?
yeah.
I thought the Montgomery constants were just based on the modulus and not necessarily on the hardware.
So it's like it's for the optimized Montgomery multiplication algorithms, it's a 64-bit value. Yeah, it's based on like taking a number that is a power of 2 that is like, so you take the size of the modulus and then you find the next largest number that's a power of 2 that is 1 greater than the I mean I won't really go into detail, but I think it is tied to the hardware, at least the anyways. I was actually kind of
thing for me to look into, I think.
Yeah. I was actually
maybe
kind of curious, like, oh, okay. Like, back on the subject of Poseidon, though, because I know you were like, I just want to hammer down on what the rationale is behind thinking that like Montgomery conversion is going to be a big overhead factor. I mean, I think you mentioned that the constant table in use would be, correct me if I'm wrong, did you say 64 values?
Yes. Oh my God, I should know this, but I don't. Yeah, it's going to be like around there. Yes.
Okay. And then the output is the output a single field element, or it's 2 field elements?
It'll be something like that. It depends on the size of the field, but yeah, it's like such that the size of the field element's output is equal to about 256 bits.
Okay. And then we're doing, so like in Poseidon, do you have did you say thousands of multiplications?
Yeah, for a single Poseidon, it should be on that order.
Right. Okay. So like we're talking about added overhead of 60 multiplications compared to an operation that's going to be doing thousands of multiplications, and I would assume like additions and stuff. So I mean, it's definitely good to quantize if we can something where the overhead of Montgomery conversion is a huge factor. That would be great to bring to the forefront. So I just I'm skeptical based on what I've seen so far.
Okay.
Yeah, so I think we can keep it as an open question. Once we have Poseidon implemented, we can see whether the overhead is large for going inside and outside of Poseidon. Inside and outside of EVMMAX memory. I agree with Jared that it's a bit weird that it is an issue. I would assume it would be an issue for things like if I just do one addition or one multiplication, then the overhead would become apparent. But there might be just something that we're missing. So yeah, it'd be good I'll put that down as a question that we need to answer.
I was mostly thinking of or comparing like Montgomery to Barrett in this context. Like I'm concerned that if we're converting all these things into Montgomery form, then it would be faster just to use Barrett at that point. That's my thinking. For some things.
Right. I guess.
But this all comes back to, I think that specking out how we define the Montgomery modulus, I think we can do this in a way that doesn't provide a lot of implementation complexity to the clients. But I will look into this and report back though. Okay.
Yeah, that'd be interesting. I think I do see where Jared is coming from as well, in that if we allow the constants to be pre-computed, you sort of leak the fact that we're doing Montgomery multiplication in the background. Whether it's an issue, yeah, I guess I'm not sure. Yeah, so I guess that's something to just think about. I don't know right now. So I'm just going to write down spec out Poseidon, probably choose a particular field to start with.
Is the use case? Sorry, Kev, go ahead.
No, sorry.
So is what we are using Poseidon for, is this non-elliptic curve based? What is the use case here?
The use case is forming a data structure that is compatible with essentially ZK proofs. And so what you use to make such a proof could be elliptic curve based, it could be based on something else.
Okay. So the choice of base field here is irrelevant to what proof system or what whether it's elliptic curve or not on ultimately.
Yeah, so what proof system you use, that will determine what finite field you use.
Right. I guess the two use cases that I can think of is, as Chance said, if you're verifying Merkle tree paths, for one, and the other one is if you're verifying Stark proofs. For Stark proofs, that does require a bit more, because the call data is probably gonna be more than the cost of the computation. There is some auxiliary stuff that I guess Stark is probably doing, like aggregating multiple proofs together. So we can probably try to not factor in the cost of call data that much as like an argument against it. Because I believe Stark where do submit Stark proofs to L1. So those are the two use cases I can think of.
Yeah, I think the argument is people don't verify stuff on L1 because there is no fast modular math. And Starkware is just an outlier where they were like, we're going to do it anyway, essentially.
But yeah, I guess what I was trying to say is that even if Poseidon was cheap, I believe that people would probably still wrap their proofs in something like Graph 16 or whatever, because the call data cost of a Stark is going to be the overriding, is going to be a lot more than just doing something like Graph 16.
Yeah, so this sort of transitions into building Merkle trees on chain, not just verifying, but like mutating them and then storing the data on chain. And that is where you do like 32 Poseidons, for example. But I think you're talking about something else. I think we're talking about different things now.
Yeah, so yeah, that's one use case. So I guess I see two use cases: the Stark verification use case and verifying Merkle paths, and probably mutating Merkle trees as well, as you said.
Yeah, but I think people wrap proofs right now just because that's the only like economically viable option.
Yeah, I agree. Yeah, the call data is a bit too much. Sorry, the proof size is a lot, so the call data cost overrides everything else.
Well, not just that, even if you have a relatively small proof, like if you have like a lattice-based commitment, it's only maybe 8 kilobytes. But if you want to prove do a ZK proof of opening on chain, the modular operations would be significantly larger in cost than the call data.
Okay, I see. This here. Yeah, so I've put Merkle path verification using Poseidon and mutation as sort of our top sort of simple use case that I think we can target pretty easily. And Jared, I guess you said that the Geth implementation's sort of there, so we can use that as one of the like as maybe the base library to just benchmark this off of. So what we'd be missing is a Poseidon implementation that we can pipe into the Geth PR that you made.
Yeah, that's correct.
Okay. And Radek, I guess for Ipsilon, is it updated with the latest 6690 EIP?
No, because as I said, it's based on the UF as far as I remember. This
Okay.
6690 is not an UF, but we can make this UF counterpart, yeah, just to compare. And so, but yeah, that's a good idea now to get it more in sync with this specification and prepare the maybe Poseidon implementation based on this and do some benchmarks. So yeah, for the next call, I think it's a good task to do it.
Okay, that makes sense. So are you going to work on the Poseidon implementation with Chance or?
Yeah, I would love to start as soon as possible, actually, but now I'm finishing the EF implementation in Solidity.
Okay, that makes sense. Chance, was you going to work on the Poseidon? Just trying to figure out who's doing the Poseidon implementation. Okay.
Yeah, and I can provide some like a field and some constants to help with this.
Okay, this is great. And I guess you might want to work with Jared to figure out how do we integrate this into Geth so that we can actually see the full pipeline of here's the Poseidon implementation and here's how we pipe it into Geth and here's the numbers. And if we want to modify it, this is the pipeline to modify it. Jared would probably be the best person to help with that.
Yeah, feel free to ask any questions. I would say that the templating tool I posted for the BLS contracts is probably a good reference to use for how to interact with Geth. You might choose to build your own assembly generator. That's fine. But if you run into any issues, though, feel free to ask me.
Okay, yeah, I think you will do.
Okay.
Do you think it makes sense to write a simple Yule generator? Would you be able to do anything with that, or should we just stick with the Huff thing for now?
I haven't looked at Yule in a long time. My fear with Yule last time I looked at it was that like the way opcodes are expressed in Yule, instead of just like, so if you take Huff where it's basically the byte code, it's basically the opcodes themselves just one by one, and then you can add functions and macros and whatnot. Last time I tried to use Yule, the way to express the opcodes was by this, like you call the syntax was strange, and I didn't find it suitable for my liking, but I mean, go ahead if you feel otherwise.
Okay.
Yeah.
Let's stick with the Huff thing, I think, for now. Sure.
I think I personally think it's simpler, but
yeah. Okay, cool. Are there any other questions that people are thinking of or things that we should discuss?
I have one more. I want to discuss a modular inversion call. I think we talked about it a bit in the chat. Are there any thoughts around this? I think it would be useful to have as an opcode, but I could also see it being implemented as a sequence of instructions.
What do you feel where do you feel like the overhead from this becomes dominant? or not, if not dominant, a large factor.
I think the control flow around implementing modular inversion is tough because if I remember correctly, there are some conditionals, so you can't even just like unroll it to get rid of most of the control flow. I also think that, or I know, okay, this is a separate thing, but you can batch modular inversions to make them faster. I have no idea how we would expose that as an API. I just have like this suspicion that implementing it as an opcode will be significantly more performant, and it's something we have to do like pretty regularly.
Could we just benchmark that? That seems like something we can verify. I mean, my suspicion is that that's true as well. But it'd be good to just have numbers that support.
So in the template tool I posted, there's an implementation of modular inversion for BLS, using the Fermat for I don't know how you pronounce it, but the modular inversion via exponentiation.
So using AdChain also? Will this?
Yeah, using AdChain. Yeah.
Okay. So yeah, that's one option. Another one is, as far as I know, is the Euclidean extended Euclidean algorithm, but not sure which are now best, because this AdChain is not the general, so it has to be generated for every model. So yeah.
We could also look at the modXP precompile for this case. I think that is probably it might be more expensive than AdChain, but from a code, in terms of how much code size it occupies, it's much less. Yeah, I don't know. I think it's an interesting area of research. It seems like adding dedicated inverse would be really complicated, though, relative to what's already in the spec. But I mean,
Agree.
Why would it be complicated?
Because I mean, what's there already? So add and sub are just both addition and subtraction, basically. Big int addition and subtraction. The set mod opcode is fairly simple, and then the real meat of the complexity here is the Montgomery multiplication, which is also I mean, maybe it's on par with the complexity of extended Euclidean. I mean, not really, because it's the modular reduction is all like constant time, basically. It just seems like adding inverse would be the most complicated thing yet in this proposal.
Yeah, right now it's essentially just a very thin wrapper around Montgomery, and adding inversion is adding like a whole new algorithm into the mix.
So the complexity is coming from in the backend or whatever cryptographic library you're using will now need to implement like the extended Euclidean algorithm, or is the complexity like gas costs, figuring out the gas costs for inversion? Like,
I would guess both. Like, yeah, correctness, but then by identifying the worst case inputs to the inversion. But maybe identifying worst cases is not actually that hard. I just haven't looked into it.
Okay. I mean, it sounds like it's something that's good to investigate, maybe as a low-hanging fruit. I guess if we have constant time algorithms, then it's probably easy to figure out the worst case. In my head, it's more like what is the usage of inversion? Like if inversion is used everywhere, then everyone's gonna have to re-implement it, right? In their contracts. But if it's only used in one or two places, then I think it doesn't make sense to have it as a dedicated opcode.
Yeah, I think that's a good point. I mean, I wouldn't be opposed to adding it. It it, it just doesn't.
Mhm.
Yeah, the justification just isn't there right now.
Yeah, yeah, I agree. I think
I
yeah,
agree too.
if
Yeah. So let's check it, and then we can decide on the next call also, or have or at least have some more input on it.
right, right, that makes sense. Okay. So I've written down the stuff we've discussed. I'll paste it in the chat. So for Bezier and ETH.js, I guess the next step would just be to looking to add a modular arithmetic lib. This is sort of the precursor to implementing the EIP. For a chance, I guess you're going to spec out the Poseidon and add a Poseidon implementation using Jared's tool or some Yule tool. For Jared, I guess you'll be helping Chance integrate this implementation into the Geth codebase. And some stuff that we need to investigate is whether we need to pre-compute the Poseidon constants or not, or whether it's like efficient enough to just convert them on the fly, and then investigate whether the opcode inversion is so costly that it needs to be an opcode. I guess, and also investigate whether inversion's used a lot in the use cases that we care about. Is there anything I missed, sir?
I guess just like to tack on to the point about inversion, investigating whether it's used a lot, but also used in a way that makes batch inversion not viable.
And also used in a way that makes batch inversion viable. I'll write that down. I don't completely know what that means because are you saying that
Like, so there's if we need to compute multiple modular inverses, we can use Montgomery batch inversion, which just boils
Hmm.
down to converting one inverse under the hood and then
Mhm.
some multiplications on top of that. But I'm
Mhm.
like, you could imagine some kind of computation where the result of one, what you're computing the inverse of in a subsequent step depends on the inverse from a prior step where you couldn't batch. I don't know if that makes sense, but essentially just identifying if there's cases where using Montgomery batch inversion doesn't isn't possible with the given algorithm.
Okay. Okay, I see.
Because
That
if
makes
we can
sense.
use batch inversion in a lot of places, it feels like less of a justification for adding. It is, well, it's obviously less of a justification for adding dedicated inversion. But I mean, yeah, maybe it's not. Anyways, yeah.
Possibly. Because batch inversion does actually still do an inversion. So I guess we can investigate further. The most important ones, I guess, is the pre-computing the Poseidon constants. And yeah, that's just to get the full pipeline of what's happening. Is there anything else we've missed?
I guess I just want to ask, how are we doing on time? Okay, we still have a bit. So like when I implement this for Geth, it's pretty easy in Geth. I think I saw a comment from somebody, Lewis, getting on and off of native code has a cost. Like when I implemented the arithmetic in Geth, it's pretty easy to map what you're implementing to the hardware. I think Go does a decent job of that, and it's pretty easy to implement this stuff performantly. And I guess I would wonder if like they're like uh C# or Java, if you have if not having uh a close handle to the hardware would make implementing the arithmetic difficult. I mean, yeah, I guess people would have to find that out as they implement it. I'm just curious.
Yeah, so in Java, I can speak for Java. It uses a JNI, so a native interface, and you need to build a context every time you step onto the native code. So that has a bit of a cost. But I think getting into native code is less costly than getting out, than calling some managed code out of the native code, which is not going to happen in this case. We're only going to be getting to native code and jump back. So yeah, that's really the gist of it.
Okay, I see. But the
Java
context.
21 introduced a new native access method that's not JNI. JNI has gotten known in overhead issues. This might be the right time to investigate using the new stuff. It hasn't been available in previous versions of BASIC because it was based off of stuff like Java 17 and Java 11. But in Java 21, that's the new base. That's where it's in. So it might be worth investigating it now. You might get better performance.
Okay, cool. Yeah.
Dano, what was that called? Java 21.
FFI, I think. I can't remember the exact. This Project Panama. They have some formal name for it now, but it was in preview in
Okay, I
prior
see it.
versions, and in 21, it's the new stuff.
But Dano, correct me if I'm wrong. I think it's mostly the efficiency is more around memory, passing memory slots into native, or having access into of memory in native code. But I think not sure. Like the context, you don't need to build it as well. Still all the same. Definitely worth investigating.
I guess I'd imagine that you'd create the context object in the, let's say, the C code, and then you just pass a pointer. You have the Java code hold a pointer to it. So your memory is managed in sort of the C code or the Rust code or whatever efficient library you're using. Or does that make sense?
I think there's facilities where you can call basically the library directly, kind of like GNA, with less steps and less overhead.
Okay, I see.
Definitely worth investigating. Yeah.
Jared, does that answer your question?
Yeah, sort of. I guess we'll just see where the numbers pan out over time.
Yeah, also worth considering .NET. I'm not sure. I cannot speak for them. Since there's no one from them on the call, I'm not sure. But .NET would be another VM that will have this problem.
Right. Anyone else have any questions? Okay, cool. Yeah, so yeah, I guess we're gonna finish early. That's great. Yeah, if there's nothing else, then yeah, I'll see you guys on the Discord chat.
Just maybe Happy Christmas and Merry Christmas and Happy New Year, because
Thank
we
you.
are seeing each other again after.
That is true. Merry Christmas.
Merry Christmas.
Yeah,
all.
Merry Christmas.
Happy holidays.
Take it easy.
All right. See you guys.
See you around.
Bye.
Bye.
Thank you all.
See you.
Thank you.